Alright, so this is Mr. Harding here so that we can go over 2 exercises like I typically do after the notes before you work on the exercises by yourself. First thing I would do, cross off that 6.6, make it a 5.5, put your name at the top so that you have everything organized. We're going to do numbers 1 and 9 together. So starting with number 1 right at the top here, we actually have, excuse me, we have talked about this example before. This is David's iPod. He's got about 10,000, not page 440 songs, he's got about 10,000 songs. The distribution of play times for these songs is heavily skewed to the right. So like what that would mean is, like, think about songs here. So most songs are around 3 minutes, 3.5 minutes. And so like you're looking at maybe a distribution here, and we've got maybe like 3 minutes here, and we have like this nice peak. But you know, every now and then you got like that 5-minute songs, or maybe that 6-minute song, or maybe even like an 8-minute song, and there's not a lot of them, and that's what gets that like strong skewness. So that's like an example of what we're looking at. A, describe the shape of the sampling distribution if you were to take simple random samples of size 5 from the population. Well, if you were only to take a sample of size 5, the sampling distribution of X bar will still be skewed to the right, because n equal to 5, so a sample size of 5 is not large enough for a heavily, and I'm going to put it in quotes just because it's exactly what they said, heavily skewed distribution. And I'm also going to put in parentheses, remember, our sample size is 30, and 5 is a lot less than 30. Not that our sample size is 30, I apologize. That's what we're hoping for. We know by the central limit theorem, if it's stronger, or if it's more than 30, we'll be good to go. One other thing to note here, and you can write this down or you can just keep it in the back of your mind. The skewness of the sampling distribution won't be as strong as the population distribution. Okay, we did sample I don't even want to say a decent sample size, but we sampled something, so it's going to be a little bit better, but not by a lot. Letter B. Describe the shape of the sampling distribution for simple random samples of size 100. Well, that changes things. So letter B down here, we would say something like the sampling distribution of X bar will be approximately normal by the central limit theorem. I'm going to abbreviate that CLT, and then I'm going to put in parentheses 100 is greater than 30. Right? Our sample size, remember again, central limit theorem says if our sample size is greater than or equal to 30, then that'll allow me to have a sampling distribution that's approximately normal. And not only is this greater than or equal to 30, it's a lot greater than. So we'll be good to go with this. All right, go ahead to number 9. Take some time to read number 9. Number 9 is talking about lightning strikes. And letter A is a lot like the question we had just done. One thing to note is as you read this, it doesn't say anything about a distribution. It just says that it has a mean of 6, has a standard deviation of 2.4. We randomly sampled 50. Nothing else. And so, if I don't know anything about the population, then I certainly don't want to assume that it's normal. But good news is our sample size is large enough, so by the central limit theorem, the sampling distribution would be approximately normal because our sample size is large. And I'm just going to, again, put in parentheses, 50 is greater than 30. Right? So our sample size of 50 lightning strikes is large enough to give us an approximately normal distribution. So, since it's approximately normal, now I can answer letter B, and I'm going to answer letter B exactly like what we did in 5.4, which I'm going to take the opportunity to talk about this now since a lot of you weren't here on School on Monday. This question was not answered well on the quiz, and remember, guys, when you take a sample, and it's the same thing, like this is what really confused me. We talked about this in terms of interpreting the sampling distribution's standard deviation. As the sample size goes up, our standard deviation goes down. A lot of you on the quiz, this was number 5, something similar to this, you never changed the standard deviation. Remember, that's the whole point of sampling. The bigger our sample size, the smaller our standard deviation. So remember these formulas, right? The mean is equal to the mean, which was 6. The standard deviation of x bar is equal to the standard deviation over the square root of n. Remember how the sample size makes a difference? A lot of you didn't do that on the quiz, so please remember to do that here. 2.4 divided by the square root of 50. So that's going to change my sample size a little bit. Give me about 0.339 for my standard deviation. Now I can make myself a rough sketch. Mean is in the middle. Most people like to write the standard deviation off to the corner. And I want to look less than 5. So I've got 5 down here. Less than that would be everything down here. So now I'm going to my calculator. And I'm going to do a normal CDF, my lower bound, my upper bound, my mean, and my standard deviation. And I find out that that's next to nothing. It's not going to happen. About a 0.0016. So about a 0.16% chance. But what you notice is what we did there in letter B, that's exactly what we were doing in 5.4. We're still doing the same thing. It's just, honestly, what we got, what 5.5 talks about. And I'll even write this down. You guys can add it to your notes if you want to. This is what 5.5 did for us. Gives us a second option to check for normality in sampling distributions of sample means. And I put this in all capital letters in case you didn't listen to the video yet. This is only for sample means. Don't do it for sample proportions. Okay? But that, I mean, that's all 5.5 is. It just gives us a second option to check. So now if my population's not normally distributed, I just make sure I have a big enough sample size and I'm good to go. Alright, so the questions that you should do then, they're on Schoology, but in case you're too lazy, they should be 2, 5, 6, 7, Oh gosh, I want to say 10, 11, 13, 15, and 17. Give me a second and I'll double check them quick. I think that's right. Give me a second, I'll double check. 2, 5, 6, 7, 10, 11, 13, 15, and 17. Yep. So, please work on those, get those finished by Friday. That's something we're going to go over on Friday. If you have any questions, just let me know.